Hello friends, welcome to engineering tutorial. So in the next series of videos we'll be focusing on energy of simple harmonic motion. Okay, so the energy of the body or the object which is undergoing simple harmonic motion. The previous set of videos we covered the basic the important parameters associated with SHM, that is the amplitude, frequency, angular frequency, time period, velocity, acceleration, all that. Next series of videos it will be related to energy, that is kinetic energy, potential energy, total energy, like that. Okay, so this is the first question. It is given that a body of mass 1 kg, it is executing simple harmonic motion given by the equation x is equal to 6 cos 100 t plus pi by 4 centimeter. We have to determine the maximum kinetic energy of the body. Okay, now first the standard equation of SHM, it is given by basic SHM equation format, that is x is equal to a cos omega t plus phi. A is the amplitude which is here 6 centimeter. Okay, then angular frequency omega is equal to 100 radians per second. Initial phase angle, that is pi by 4 radians. Now the kinetic energy of an object undergoing SHM, that is given by the equation 1/2 k a square minus y square. Okay, that. But here we will use a very direct approach, no need to go by this. We have been asked to find out the maximum kinetic energy. So for that what we can do is we will find the maximum velocity. Okay, also kinetic energy we know is 1/2 mv square. So this will be maximum when velocity will be maximum, and we know that the maximum velocity in SHM is given by omega a, where omega is the angular frequency, a is the amplitude. Here omega is equal to 100 radians per second and amplitude is equal to 6 centimeters, right? This. So instead of that we will write it as 600 centimeter per second, it will be 6 meters per second, because 6 into 100, 600 centimeter, that becomes 6 meters. So 6 meters per second, that is the maximum velocity. Then mass of the object, that is given 1 kg. So simply we'll put this, the maximum kinetic energy Ek max is equal to 1/2 m V max whole square, which is equal to 1/2 into 1 kg, and this is 6 square, that is 36 by 2, that is how much? 18 joule. So that is the maximum kinetic energy of the object undergoing SHM as per the data which is given in the question. Okay, this. So a very simple and straightforward introductory question related to energy or the maximum kinetic energy of the object or body undergoing SHM as per this relationship. Okay, so this is another question on energy of an object undergoing simple harmonic motion. So it is given that a particle executes SHM, that is simple harmonic motion, with amplitude small a, at what distance from the mean position will be its kinetic energy equal to its potential energy. Okay, so here the basic SHM equation format. Let's say y or x, whatever you can take, y equal to a sine omega t. Here no information about initial phase angle is given, so we'll keep, simply keep it as it is. Now for this, if the particle or the object has a mass m, okay, here a is the amplitude, omega is the angular frequency, the kinetic energy of this object is given by 1/2 k a square minus y square, where k is the force constant, okay, which is given by k is equal to m omega square. The angular frequency is also given in terms of this, by this. Now the potential energy, that is given by 1/2 k y square, okay, where y is the instantaneous position of the particle undergoing SHM. Okay, suppose this is the equilibrium position. On this side, the positive extreme, we have plus a, and on the negative extreme also it has this y, and from this equilibrium position, okay, this particle, it undergoes simple harmonic motion like this. So the particular position where the particle is located, the distance or the displacement of that position from the equilibrium position, that is called as the instantaneous position. We all know that. So here the condition is that the kinetic energy and the potential energy, they should both be equal. Okay, so that means we will bring one equation, that is of kinetic energy on this side, a square minus y square, and the potential energy expression on this side. So here k by 2 or 1/2 k, 1/2 k, that will get cancelled. So we will be left with a square minus y square is equal to y square. That implies 2y square is equal to a square. Okay, that implies y square is equal to a square by 2. That implies y is equal to, magnitude wise, it is a by root 2, that is equal to 0.707 a. So at y is equal to a by root 2, magnitude wise, that is on either side of the extreme position, the equilibrium position, on both the extreme ends, on the left hand side and the right hand side, here at 0.707 a, this position on either side, it is actually plus minus a by root 2, because both sides are taken into consideration, but if we only take magnitude, it is simply a by root 2. So at this position, on either side, the kinetic energy and the potential energy, they are both equal. Okay, so this is the thing. So basic understanding of the formula of kinetic energy and potential energy, simply we just equated them and we got the result.